So let's jump into the deep end and make our own BlinkScript kernel. Specifically, let's make a variable defocus BlinkScript kernel, kind of like a Z defocus. We're going to make it a little bit simpler just to get the key concepts out there. But this is a really great first step because making a defocus has so many little bits and pieces that all come together to create a complex output, and is a really great introduction to writing our own first BlinkScript. So the first thing we're going to do is we're going to grab our blank BlinkScript kernel, and as we will remember from the previous video, all this does is it takes our source and outputs it to our destination, like so. So there's no change. Now I've grabbed a checkerboard, but what I'm going to do with this checkerboard is I'm going to add some noise. And the reason I'm going to add some noise, and I'm just going to make it a really fine, crunchy noise, something like, let's push this a little bit further. Something like this, is so as we are defocusing our image, we actually have something we can see. Because if we didn't have that noise, it would just look overall quite soft. And from this you can probably figure out if your defocus is working. But I like to make sure we've got a really, really crunchy set of information so that we can really see those kernels. Now the next thing we're going to do is within our image, specifically within our image section of our BlinkScript kernel, where we read the image or how we access the pixels, we need to address this in a slightly different way. At the moment, by default, BlinkScript does something called access point. And if you don't include anything, like the way we're writing our image here, has nothing, but we could do the same thing where we write access point. What this does is it goes across your image pixel by pixel, and it says, okay, as I'm processing this pixel, I'm only going to access the source from this pixel. And as you move across pixel by pixel, it does that same thing. Now, there are 4 different ways we can access our image with BlinkScript. The first is access point, which only accesses this one pixel. The next one is access ranged. If I can spell it correctly, it'll change blue. Range 1D. And what this does is it will access your image in one dimension, either in X or in Y, depending on how you specify it. You have access 2D, which will access the image using 2D coordinates from your origin pixel in the middle, or you can access random. And if I do this, it will go blue. And access random allows you to directly access any pixel on the image by giving it the direct coordinates as opposed to the relative coordinates. And for this, we're going to be using access ranged 2D, because when an image defocuses, it goes out from your central pixel, and that's how we want to access our pixels. Now, when we're dealing with access range 2D versus access point, there's a few extra steps that we need to do. And this is specifically, we need to tell our BlinkScript how large of a range to expect, and we need to tell our BlinkScript the relative coordinates of the pixels that we want to work with. So the way we set the range of our ranged 2D is we come down to the init section of our BlinkScript, and this is what will be ran when it initializes. And we need to just make a new line and tab in, and we need to write a little line here that says source.setRange, and you'll see it goes blue, which means it's working. We want to make sure we put a semicolon at the end of our line here. And the reason we want to put that semicolon is because that is how in BlinkScript, which is similar to C++-like languages, how you finish your line. Those of you familiar with Python will know that we could just leave it like this and it would run fine. But when working with BlinkScript, you need to make sure to leave this in. Otherwise, you spend forever trying to figure out why your code doesn't work because you just left out a semicolon. And now when you're doing set range, you need to actually set the values. And the way this works is you specify your negative X, like so. Then you specify your minus Y, and let me just click in here, minus Y. And then you do your X and then you do your Y. And so what this is doing is you're telling BlinkScript, okay, we're going to have values this far in minus X, this far in positive X, this far up, and this far down. But you don't just leave minus X, minus Y, etc. in here. We need to actually specify the numbers. And in order to specify those numbers, what we need to do is we need to create a parameter that will control them. We need to create a parameter that is going to control our defocus size. And the way we do that is here in our parameter section here, we're going to write int, which will create an integer variable, and we're going to create the variable called defocus size. We're going to put a semicolon here. And then additionally, what we're going to need to do is we're going to need to now define this parameter that we've just made. And the way we do that is within the define section. And the way we're going to do this definition is we're going to say, okay, define param, which is obviously short for define parameter. Next up, we have to give the name of the variable that we're going to define, which is obviously defocus size. So I'm going to copy and paste this. Next up, I'm going to do a comma, and then I'm going to put some quotes here, and I'm going to say what I want to name this variable. And this is this name is what's going to appear like all other nods on Nuke nodes, like so. And so this we're going to write in a sort of more user-friendly way. So we're going to call this defocus size, and then we're going to put a comma, and then we're just going to define the default value. So for example, on this one, just like the regular defocus node, I'm going to Control-Shift-X to pop this out. The default defocus node, as with most filters in Nuke, you know what, this comes in as a default of 1. So let's define this to have a default of 1. I'm going to put a semicolon at the end here. And now, when we recompile this, we are actually still going to have an issue. You can see we've got an undeclared identifier X. And what this means is that where here we've set the range, these X and Y's that I was using for demonstration aren't correct. They haven't been defined as anything. So what we're going to do is we're going to copy the name of our defocus size, and we're going to paste that in these boxes here. And what this is doing is this is saying, okay, the range that we need to access our pixels is never going to be greater than the defocus size we're feeding it. Now, when we click recompile again, we're going to see what our next issue is that we need to solve. Now we can see that there is an error on line 32. Now if we go down to line 32, we can see this is where we are accessing our source image. Now you might remember, as opposed to using access point, when we're working in access ranged, we need to give the coordinates of the pixel we want to read. So for this, we're going to say 0, 0, which is reading our origin pixel. You can see it looks a little bit like an owl, which is how I like to remember it. Now when we click recompile, you can see we're feeding through our image nicely here. But now when we go to our kernel parameters tab, you can see we have this defocus size integer knob, and I'm middle click sliding here to change those values. I'm going to set this back to 1. Now the way reading these coordinates works is quite interesting. It's slightly different to how you might expect. Now when I see this and I see these coordinates, my mind is immediately sent to the transform node, or maybe the position node, which allows you to translate your image in X and Y, and the transform node obviously has lots more. But if I, for example, put a value of 5 in this box, you can see my entire image is moving 5 pixels to the right. But if I was to put a 5 in my X coordinate here, because this is X and Y, when I click recompile, you can see the opposite is happening. My image is moving 5 pixels to the left. And the reason for that is because what's actually happening is it's pulling the pixel. So if we take this black pixel as our center, we're going 1, 2, 3, 4, 5. You can see we have this nice gray pixel here, and it's pulling that 5 pixels in the opposite direction. So you can see when this is disabled, it's here, and then when it's enabled, it's 5 pixels to the left. And this is a good way to check if our parameter is actually working. What I can do is I can grab this integer here, put this in this box, recompile, and you can see now as I move this slider, our image is moving with it, which is great. That means that so far everything is working as we'd hope. Right, now that we've got the skeleton of our BlinkScript sorted out, let's see about actually getting ready to do our defocus. Now, when I'm working with BlinkScript, what I like to try and do is start from Nuke native nodes. For example, using a transform here to deal with this pixel offsetting, because this is something that Nuke native nodes, I think, we're more familiar with than necessarily starting our BlinkScripts from scratch. So for a defocus, what we need to do is we need to actually take a look into convolving. So the way we're going to do this is, first things first, we're going to create a radial, and we're going to use this as our filter to convolve the image by in order to create our defocus. And don't worry if this sounds a little bit abstract at the moment, it will all make sense. And then what we're going to do next is we are going to create a reformat node. We're going to set this to box. We're going to force the shape, and for now we're just going to do 15 by 15. And now when we plug our radial into this, you can see it's much too large for our small little box. And so what I'm going to do is I am going to make some expressions here. And so the first one, I'm just going to do 0, 0. So the bottom left corner of my radial is always in the bottom left corner of my format. And then on this one, I'm going to write width. And on this one, I'm going to write height. And then after that, I've accidentally set a keyframe. What I'm going to do is I'm going to set my softness to 0. And now what this means is, and just for the sake of simplicity, I'm going to control click and expression link this here. It means as I make this bigger and smaller, we're getting a larger and smaller radial. And now what we can actually do is create a convolve node. We're going to use this radial as our filter. We're going to plug this noise node in as our image. And now when we plug this into our convolve, you can see we are defocusing our image. And that's what, on the inside, effectively, that's what a defocus is. So if we do the same thing, this one, so we're going to set this to 15, and then we're going to set this to have a defocus of 15. What we might need to do here is we might need to double this and set it to 30. And so you can see these two are having very similar, they're not exactly the same, but they are very similar results. And so this is a great way of getting like an estimate of what we are going to be working towards. And so you can kind of see our steps that we're going to be building in our BlinkScript kernel. We're defining the size here, which is what we've done with our defocus size. Now we need to make a radial, and then after that we can focus on convolving. So the theory of how this is kind of going to work when we go to write our pixel and how we actually write the convolution is our BlinkScript is going to internally have a radial like this, a sort of virtual circle that it's going to be considering when it's going in our image. And what it's going to do is it's going to cycle across this virtual circle as we go from the center of our pixel outward like this in our sort of in our convolution. And then what it's going to do is it's going to say, okay, I'm going to walk across every pixel in my image like this. And if I come across a pixel that isn't black, like these pixels here, I'm going to add them all together. And then we're going to keep going along, and it's going to do the same. It's going to say, okay, I'm going to add this pixel. And when I say this pixel, I'm talking about this pixel relative to the central pixel that we are dealing with. So if I merge this over the top of this to make this really obvious, and I'm going to create a black outside node around this, and all this is going to do is it's going to add an extra row of black pixels so we don't get this smearing. So if I were to just transform, and I'm going to transform this by integers, if I was to transform this over, and I'm just going to reduce the transparency a little bit, and to make it really obvious, I'm going to make this just red. And so what it will do, let's tidy this all up a little bit so it's nice and visible. Right, so what this will do is it will start from the central pixel. I'm going to pick a different color so that we don't clash. Brilliant. So it will start from the central pixel, and it will go out by the width and height of our radial, and it will walk across, and it will say, okay, any pixel that is within the radial, I'm going to add together like so, and it will add this pixel, this pixel, this pixel. It will ignore the pixels outside the circle. It will combine all of these together. It will then average them all by dividing by the number of pixels it's counting. And then it will assign that value to the center. So it's basically taking an average of all of these surrounding pixels. So that sounds quite easy to say, or maybe it doesn't, but as we go step by step, it will. But the first thing we need to do is say, how do we actually define a circle using just code? Now, again, before we jump into BlinkScript world, let's see if we can do this with a Nuke native node. And I am going to grab an expression node for this, and we're going to write an expression to define a circle. So let's start by first defining one of our expression variables. We're going to call this one radius, and we're going to use this to drive the, you guessed it, radius of our circle. Now, if we look at our expression node and we just type radius in here, the whole thing is going to have a value of 50 because that is the value of our radius. And I'm just going to plug this into our checkboard. I'm going to delete a lot of the stuff we don't need anymore and just keep everything nice and tidy. Let's square this off. We'll start working over here. Brilliant. So this has a value of 50. Now, what do we need to do next in order to define our circle? Well, a circle, we need to use our X and Y coordinates. And rather conveniently, if I write X and Y in here, we're going to get this very, very bright image. But wow, this is actually very pretty. You can see as we start in the bottom left-hand corner, our green, which is our X, and our blue, which is our Y, are at 0, 0. And when we go all the way to the top right-hand corner, you can see we've got 1919 and 1079. And the reason for that is because we started from 0, and then you count all the way up, and it's 1 less than the format because we started from 0. So next up, what we need to do is we need to look at a power function. Now, the way you do this in an expression node is you can just write pow, which is short for power. And so I'm going to do this in a new section. So if I here write pow and then put my brackets, x, comma 2, that is going to do x squared, which would be the same as writing x to the power of 2 like this. But the reason I'm using this power expression is because this is supported within BlinkScript, whereas this double asterisk is not. Now, what we're going to do is we're going to subtract this from our radius, and I'm just going to 0 these out so it's nice and easy. And you can see here we've got this fall off in our x coordinate. Now, next thing we need to do is we need to do the same thing with our y coordinates. So to do that, we're going to do pow again, and we're going to square it. And you can see here we have this very interesting sort of diagonal, almost diagonal line. You can see it ramps up just a little bit here. And now what we need to do is we need to actually put some square brackets, not square brackets. We need to put some brackets around these so that these get added together before the subtraction happens, which means we get this very nice little circle here. And now at the end, I'm going to write I'm going to turn this into an expression. And the way we're going to do that is we're just going to write greater than 0. And what this is going to do is it's going to return 1 when this value is greater than 0, as opposed to a sort of sliding ramp. And if I make this number bigger, you see this becomes quite obvious. I'm just going to say we want 1 or 0. And now we've just turned it into a question. So now that we've done this, something you might notice is that actually we don't have a radius. If I do, what I'm going to do is I'm going to move this into a different channel so it's more visible. You can see that this radius is only 23 pixels, not 500. And the reason for that is because we need to do an extra step. What we need to do is square root our expression here that we're subtracting from the radius. And the way you do that is you just do power, and then we're going to do this entire thing to the power of 0.5 like this. And now you can see when I move my slider out, this has a width of 500 pixels. Now, you can either leave it like this, or there is an expression that is available within BlinkScript, which we can take advantage of here just to show multiple ways to do the same thing, which is you can actually write squirt, short for square root, here and achieve the same thing. And now we can see if I write 700 in this, we get a 700 radius like so. And this is all pivoting around our 0, 0 origin. So this is actually expanding out into this area here, but we're not writing those pixels because they're outside of our bounding box, those negative pixels. But when we go and move this over to our BlinkScript, those will be useful. So we're going to leave our expression here for a moment, and we're going to move on to the next little bit. Although, because our filter is going to pivot around the 0, we don't need to change this. If you ever do, for other reasons, want to control your radial like this, and I'm going to make this just a little bit smaller so it's easier to deal with, you can do an offset here, and similar to pulling the pixels from other places, it's a negative value. So you could do minus 500 by minus 500, for example, and you can see what this has done is it has offset the center of the pixels to be at, I could get this exact, but it's at minus 500, minus 500. So what I like to do with this sometimes is I will create like a 2D position knob, and I will call this center. And then I like to do minus center.x and minus center.y. And we don't necessarily need that for what we're doing, but this might be useful for some other stuff you're doing, just to kind of explain the concept as just a little freebie bit of extra knowledge.